parts. With over 10 years of experience, he has contributed extensively to composite materials, 3D printed electronics, biomedical implants, and 4D printing. He has published over 55 research articles, presented at national and international platforms, and received the IEI Young Engineers Award. His work has attracted research fundings of over 1 crore from leading agencies like ISRO, SERB, and BIS. We are delighted to have him here with us today. Sir, the virtual lab is now yours. You may take the screen.
Uh, Thank you for such a nice introduction. So very good afternoon to all of you. I hope I am audible to all, right? So before I begin, let me share my screen first. Then we will start talking about the MATLAB and Mass Mixer software, right? So initially, I will be starting with the PowerPoint presentation because I will discuss few points regarding the use of MATLAB and Mass Mixer, right? And after that, we will go for the hands-on demonstration. Is my screen visible to you, Vishal? Can you confirm? Hello?
Not yet, sir.
Not yet. Oh, but I am getting message. Yeah, now.
Yes, sir. Now it. Yes, sir. Yes, sir. Now it is visible.
Okay.
Okay. Thank you, sir.
Okay. So you can see here I have chosen two softwares, right? Because the theme of this particular FDP is related to the digital transformation of additive manufacturing or in additive manufacturing. So that's why I have chosen two softwares, right? One is the MATLAB that you are aware with this. It is very popular software, right? And second is the Mass Mixer. So I will also tell you the applicability and the use case of Mass Mixer. In what cases you can go for the Mass Mixer for STL manipulation. Okay. So let me begin with the MATLAB first, right? So here the content which I'm going to cover in today's practical session, that is the introduction to MATLAB. Then we will have some basics of the MATLAB, like few commands, right? Then application of MATLAB in additive manufacturing, right? Means in what conditions we should go for the MATLAB if you are working in the area of additive manufacturing, right? In which case you should go for MATLAB, or in which case you should not go for the MATLAB, okay, or for the programming. Then we will see few manual programs, right, which we have prepared by ourselves. Okay. Then I will be talking about the very important topic, that is the development and deployment of app in MATLAB. Because nowadays we all are dealing with different kinds of app. Okay, whether it is the e-commerce websites where also they have launched their apps, whether it is related to the restaurant, there also we can see some apps in the market. So nowadays everybody is dealing with the apps, right? Because interaction with the apps is quite easier. If we want to get some output, we can directly deal with the apps and we get easily. So we will see how to develop a app in the MATLAB, okay, and then how to export the app in the form of executive files. This app can be installed in any computer system, right, irrespective of the MATLAB, whether it is installed in that particular computer or not. So you can export the developed app as a executive file, exe file. So that we will see how can we do this, okay. And after this, I am going to talk about the STL manipulation, why it is required and why it is essential, because most of us who are working in the area of additive manufacturing, they do not know the importance of STL manipulation. What they do, they directly make the model, right? Then they export the model into the STL file. Then they go for the printing. Okay. But sometimes your STL file may have some errors. So those errors may, affect the quality of the products which you are printing using any 3D printing process, right? So it is very important to check the STL file. If suppose you want to rematch the STL file, then how can you do it? So these things we will see in detail, and I have few case studies that will also be discussed. Okay. So let us begin with the introduction to MATLAB. So when you open MATLAB, right, this type of window actually is, appeared in front of you after me's opening, right? So here you can see that here we have the editor window, right? This is the editor window. So this window is used to, write the script. We can write the functions. Okay, we can develop function. I will give you one example where I have developed a function of circle, right? So when you call the function in this editor, basically window, automatically it will read the circle or any function that you have defined. Okay, and if you want to check your code debugging, right? If any error is there, you can line by line you can check. If any error is there, you can check and rectify. Then third is the code execution. So you can execute the code, you can check the output, okay, and you can also perform these things in this. And here we have the command window, right? So if you want to execute a command in MATLAB, so directly just typing in this window, you can execute any command, right? Suppose I want to assign some value to some variable, for example, a equal to 5, right? I want to define a and I want to assign value 5, okay? So I can directly write a equal to 5 and this value will automatically assign to a variable, right? And we can directly run the scripts in the command window and we will get the output or the results. In real time, you can check the okay output of the code. Instead of going in the editor command, you can run the script directly in the command window, right? Then here we have workspace. This is workspace, right? So suppose I have assigned this a equal to 5. This variable will be stored here, right? So we will be able to see the variable and its value. So that's why here the two columns are there, name and value. Name means a, value is 5, right? And then here we have the folder directory, right? In which directory we are working currently, so that you can see from here. So current folder name is here, that is the D drive, and then slash, and then MATLAB work nk. So here you can see we have stored few functions, right? These functions, right? So all the components which are stored in the folder, you can see directly here in this particular section. Okay, and on the top you can have the home, plot, apps, editor, right? So a lot of options are available that you can access from the top. And okay, so here what I'm going to do, I'm just going to open the MATLAB directly for you, right? Uh, so this is the for example, this is the MATLAB, right? Actual window of the MATLAB. So I have opened the MATLAB, okay, to show you the the yes. So now you can see here I am having the current folder, right? And here I am having the workspace detail. Okay, so currently there is no variable stored. So as I told you, here we have the command window. So here I'm writing this equal to 5. Now what happened? When I assigned equal to 5, the A in the workspace, you can see A name is A, variable name is A, and the value is 5, right? Again, it is stored here, right? And now I want to do the A, sorry, C equal to A plus V, 9, right? So it's kind of calculator. So MATLAB basically, the full form is the Matrix Laboratory, and this software is basically designed for engineers and scientists. So this software has huge potential and huge, options which can be used directly for the research purpose and for solving many problems. Okay. Similarly, if I again uh, do the multiplication, so we can do in this way, right? So if you have MATLAB, you can practice these things. Okay. Same thing. This is the command window. So as I told you here, that in the command window, we can execute the command directly, right? We can run the script and or we can interact with the variable in real time. So when I'm writing anything here, right, immediately I'm getting the value, right? So I'm directly dealing with the variable in the command window. Now suppose I want to clean my command window, right? Clean the command window. I do not want anything here, right? And so I will simply write CLC. Okay, clear screen. So now what has happened? All the variables which have been executed in the command window, now they have disappeared. They have been disappeared from the command window. How? By just using the CLC command. Clear screen. Okay, but still the values are stored in the workspace. Now, suppose I want to delete my workspace, all the variables. So two options are there, right? Either we can delete directly by clicking on the variable, right? Delete, or we can simply write clear all. So it's very simple, right? So you can practice. If you have MATLAB, you can practice these things, small things. A equal to B, sorry, A equal to 5, B equal to 10, C equal to A plus B, A divided by B. So any operation you can perform here, right? And you can store the variables in the workspace. Then just write CLC command. It will write off all the elements or all the variables from the command window, but not from the workspace, right? So work is to delete the variable and their values from the workspace. You have to use the clear all command. Is that clear? And sometimes there may be possibility uh, of like some commands, running, behind the screen, for example. So in that case, for safer side, you can also write close all. So if somebody has assigned some value to some variable, so that will also be closed, right? Close all. So everything that was stored in the directory or in the workspace or any other uh, backend sorry, screen, it will be closed. And then here addition I have just discussed with you, right? Subtraction I have discussed with, oh, subtraction you can do by your own, right? And then okay, here now let me tell you the use case of this editor window, right? So here what I've done, okay, I'm deleting it. Under the from the top here we have home, plots, apps, editor. So from the editor option, you can select new, right? New. Okay. So new Now I'm going to write my script here. So here I've already prepared my code for circle. So here I have defined one function that will have the information related to the circle. Okay, then we will plot circle after this. So in the editor window, what I can do, I can simply suppose I want to read something here. Okay, I'm about to write MN80 for example. I can write, I can delete, but in the uh, command window, if I write something, it will execute it, right? I can also enter, nothing is happening. It means I can also suppose I want to change the X to Z, for example, I can do it. So this kind of debugging and checking of the code is possible in the editor window. Second thing, for example, this let me talk about this code. Okay. So I'm just simply making this file name circle and I'm saving it. Now you can see this function has been stored. Okay, I will simply plot it. Let me check whether see I stored my function earlier, right? So circle as a function, and here I have called this function, right? I have given these values 2 to 10, right? So by using these uh, values, I have plotted a circle of this radius, right? And now, so this is the use of the editor window, right? In editor window, you can write and recheck your programs, right? And here I have, so for example, for patching, I have created one function, patching, and let me save it, patching circle, right? Then I will call it again by another window. See, now the circle has been patched. So first I have written a function patching circle. Now I am calling this function patching circle and I am giving the values, right, as per my written function. Now it is giving us a field patched circle, right? So in this way you can write your own codes, right, and you can practice things just to create the codes, right? Now let me start. Now let me give you the idea. These all are the basics, right? I'm not strict. Now just come back to the topic. Why we are discussing about MATLAB? Why we are discussing about MATLAB? What is the purpose? Why the coordinator of this particular FDP has taken this particular topic in this FDP? Why? Because MATLAB has various applications in additive manufacturing. So I will tell you, MATLAB, sorry. So MATLAB, how MATLAB can be used for the additive manufacturing? That is the I think the interest part of this. So here, before I begin with the discussion on the MATLAB application additive manufacturing, I want to discuss about the 3D printing process chain. So I hope you all know about this process chain, right? Those who are new to additive manufacturing, let me cover this process chain quickly. So here you can see, here this is the first step where we are making a CAD model, right? Then this is the second step. Sorry. Second step where we are exporting the CAD model into STL file. Okay. Exporting the CAD model into STL file. So STL is just the approximation of the CAD surfaces. Approximation means, for example, here we have a, for example, we have a cuboid or cube, right? And suppose if I export this CAD model into STL file, how the information will be stored? In this way. In this way, right? In this way. So means one planar surface will be stored or will be written using the two triangles, right? And here, for example, this, and two on the back side, this side, and two on this side, and two on the bottom side. So total 12 triangles will be required, right? Total 12 triangles will be required if you export this CAD model into STL. Okay. Then further, why we use STL file? Because with STL file, slicing becomes very easier. Because how do we slicing? Slicing is the process where we do the I can say the extraction of the contours, right? Extraction contour means, for example, we want to print this particular product or this part in this orientation only, right? So now what will happen? The slicing will give us the various contours along the Z direction. So how we obtain these contours? By just taking the intersection points. So we take a plane and then we intersect this STL file with the plane, right? And then by joining the intersection points, we simply obtain the contour of the part at that particular Z height. Okay. Now, here we generate the tool path. Okay. So first process is CAD modeling. Second is the tessellation or STL file format. Third is the slicing, where we generate the contours, extract the contours from the STL file. And after the extracting the contours, we go for the toolpath generation. So toolpath means, for example, here we have a contour, right, for this particular part. Now we will generate a toolpath because we have to make a layer. So how can we make a layer? By just filling this area. So many space filling curves are there, right, which can be used to fill this area or to just give you the physical layer by depositing the material. That this is our requirement, right? Because 3D printer does not know about the movement, where to move, when to deposit material. Lot of things are there. So these things are decided here only during the toolpath generation, right? And after the rest, part fabrication and post processing. So these are the machine dependent things. So I'm not talking about these things. My focus will be on this CAD modeling to toolpath generation, because this is very important, right? Because 3D printer basically is not just a hardware, right? It's a smart software also. Means along with 3D printer, we have to use a smart software that can give us the solutions like STL, file viewing, slicing, and then toolbar generation. These things are very important, right? So today we will explore how MATLAB plays a key role in additive manufacturing process. How can this software provide us the solutions to the problems related to these steps, right? How slicing and toolpath generation works, how to process and visualize 3D model using MATLAB. So these are very important things. And nowadays also some process parametric optimization is trained. So where you can apply some evolution algorithms like machine learning, genetic algorithms. So those features are also available in MATLAB. Right? I have another lecture on machine learning application on in 3D printing. So that I will try to cover. Okay. That I will try to cover through MATLAB also. Okay. Now, here I have taken the taken one case from here. Okay, but let me show you one thing. Right? Let me show you one thing first. I have just wait. Again, go back to MATLAB. Okay. Let me delete this. Suppose this code, right? This code I have written just to read the STL file and to slice the STL file. Okay, everything I am going to clear it from here. Okay, from the command window and close. Okay, not required because already we have written in the first line clear workspace. So already we have used command like clear CLC close all. Right. So when I will execute this particular or I will run this code in the editor command, in the editor window, automatically it will clear off the workspace. Okay. So to load the STL file here, I have written this function. Then to extract the geometry, so lot of things, lot of features are given here. Okay. So it is very lengthy code. So now I'm going to run it. Now you will see here from I am going to select the file name. So it is asking me to write the desired slice thickness. So for example, I have just imported or I have just selected STL file and I want to slice it. Okay. So here it is asking me to load the value. How much slice thickness you want to have in your toolpath, right? Or in your slicing. So for example, if I write, for example, if I write 5 mm, right? What will happen? I have to enter this. Now you can see it is also giving me the total number of slices. How many slices are there? 7. Right? So this is my original STL model which I imported. Okay, which I have imported. So can you tell me how many triangles are there? Anyone? Can you tell me how many triangles are there? No? Can you count the triangles? Anyone? Vishal, you can respond if anyone, no other is responding. Hello.
Sir.
Hello. Yes.
Hello.
Yes, sir.
Yes,
sir. Can you count the triangles? No.
No, sir.
Answer is simply no, right? So what does
Yes,
it
sir.
mean? What does it mean? It means that if you have curved surface, because I took one example of the cuboid or cube, where I just counted the triangles 12. Number was 12 only, right? Because the cuboid was having the planar surfaces only. But here, since it is a hollow cylinder, it is having the curved surface, right? This is totally curved, right? So in order to approximate the circular surface or this curved surface accurately, we have to incorporate the more number of triangles. So currently I also don't know how many triangles are there, but I will tell you with the help of mass mixture, we can also change the number of triangles. Suppose let's say currently number of triangles are 1000, for example. The number is 1000, right? And I want to increase the number of triangles to increase the accuracy, right? So with the help of mass mixture, I will try to improve the accuracy of this curved surface. So when I have executed my file, what I am able to see? I am able to see this circle, sorry, this triangle, this STL file, which is uh, which is having the I think many triangles of different sizes, right? And the second figure window, figure 2, I am able to see the contours. Can you see contours? See, this is a top view of the contour, right? 2D top view. So from the top, what we are able to see? We are able to see the circles, two circles for hollow cylinder. So this is for the inner or the hollow portion, and this is for the outer, right? Outer surface, inner surface, outer surface. So if I tilt this like this, what I am getting? I am getting the so this is my uh, sliced model. Okay, this is my sliced model. And here I have few options like you can also check the data, brush data. Like for example, here, yeah, I have selected one point. So there is some error with that, so it is not showing the points. Otherwise, it shows the data points. Okay, sorry. This one is the data type. Sorry. This is. See, I have selected one point, and what it is showing? It is showing the coordinate value 20 minus 1.37 raised to the 10 to the power minus 6, and then we have z equal to 15. Similarly, if I click here, it is giving me another point. Okay, the coordinates of this particular location. If I click here, it will give me the z minus 50. So that you can also verify from the scale. Okay, that you can verify from the scale. Here we have z equal to 0. Here. So this is how we can, okay, as a researcher, sometimes we need to, use some images. Okay, we should have high quality for publication purpose. So the commercial softwares, they are sometimes they do not provide those kind of qualities, right? So we can use MATLAB to generate the good pictures of the data. Okay, from the data like slice model, we can change colors, we can patch the the, and also here in this case here it is very good quality of STL file, right? I can zoom, I can also change the orientation. So according to my requirement, I can set the orientation of this STL file, and I can take picture, right? Similarly, okay, let me write another code where we will just wait. This one, I think this is the code. Let me run it if it is working. Yes, it is working, right? So here with this code, what we can do, we can load the STL file simply, right? Here we have given provision, we have added some buttons. Okay, by just pressing these buttons, we are able to select the STL file from the directory, and also I'm able to decide the let make it 2, make it 2, or make it 1.5 slice. Now you can see we are able to see the slice at 1.5. We are able to see the contour information. right? Another code I'm having, that is the yes, that is giving the STL file. Oh, yeah. So this is actually the app. We can develop our own app, okay? Because due to time limitation, I'm not covering this in detail, okay? And let me see it and clear all. Okay. Now, okay. So here, similarly, here again, I'm running this code again. What will happen? Let me show you. See, again, now I'm going to reduce the slice thickness. Okay. Now the number of slices are, total number of slices has been increased from 7 to 16. Now we have 16 slices. Now you can visualize the hollow cylinder. Okay, we have obtained the contours for this particular model. If you change the if you want to change it again, let me change it. This one here, I'm going to change it to 1. Now again, we will have the one, enter. 31 layers are there, right? So it is taking more time because the complexity has been increased now, because number of layers has been increased from 7 to check. So see, now the number of layers has been increased, right? So in this way, you can use the MATLAB to just visualize the STL file, visualize the sliced model, right? So a lot of things can be done here. Now let me tell you another case study where I have done one very interesting thing. So as I told you, tessellation slicing is very important steps of additive manufacturing. So we can do the coding for these things, right? Slicing we can do. Third is important thing is the toolpath generation. This is toolpath generation. So as I told you, many space filling curves are there, right? Many situations where we need to use MATLAB. So here I have what I've done to give you the idea about the use case of MATLAB in additive manufacturing for toolpath generation. I have generated a part program using software. Okay, so those who knows about the FDM process or triple F process, right? Cura is very popular software. Okay, so if you have a open source printer, like printer from the Ender company, or from Creality, or from any other open source based companies, right? Cura can be used. So what I've done, for a simple rectangular strip, I have generated this code using Cura. Okay. So if you look at the code, you will find the letters. What kind of letters? Here, this is M82, G92, G28. If you know CNC milling, part program for CNC milling, then you can relate these letters. Okay, G1, and along with these letters, we have X, Y, Z coordinates. X by, okay, F. So some letters are given and some of at some of the places we have numbers. Okay. So you can see these softwares like Cura, we can, what we can do, we can only use these softwares for the standard cases. For example, if you want to generate a standard toolpath which is already available in the software, you can use this, right? It will give you the code, it will give you the G code. But suppose if the requirement is not fulfilled by the software, in that case what you will do, right? So then you will go for some other software. Okay, and those softwares may not have those options which you require. Then we will go for the MATLAB or the Python, any other programming software. So how we will do this? I will show you one of my case study. Okay. So here I have given this table where you can try to understand, have a look of every, the code that generally we use in the 3D printing, right? This is basically for FDM process only, triple F, filament based 3D printing, right? So here we have codes like G28, G90, G91, lot of things are there. So I'm not, giving much detail on this. You can just see, you can relate later on. And here I have added few, slides where the necessity of customized toolpath generation is given. In what conditions you need to make a customized toolpath. So first case is the non-planar and multi-axis printing, right? So if this is a situation and your current software is not able to provide the code, in these cases, you can go for MATLAB. You can write your own code, right? You can slice the model. You can generate toolpath, customize toolpath for your machine. Okay. Similarly, second thing is anisotropic property control. Suppose I want to change the toolpath for every layer. Suppose I have 20 layers, right? And for these 20 layers, I want to use different types of toolpath. Okay. For first layer in this way, second layer, for example, in this way. Okay. Third layer, again, I am just taking this kind of toolpath, for example. Okay. So in this case, all the commercial softwares will fail because they don't have this facility. As a researcher, as a academic, person, sometimes we need to explore the things by just going out of the box, okay, or but just by exploring the things out of the box. So these things are required, okay, not to everyone, but for the researchers. For example, PhD scholars, MTech students, faculties. So in this case, you can go to the MATLAB. So this thing is there. Then if you want to deposit the gradient or heterogeneous material deposition, if you want to keep, in that case, you can make your own toolpath. And another area where you can apply the MATLAB, that is the feature-driven adaptive slicing. Feature-driven means if your micro channel, if you have overhang or something, some other features, accordingly, the local modification of layer thickness will be carried out. Layer thickness means, because in my case, in my previous example, where I have taken the layer thickness of 1 mm, for example, right? Now, with 1 mm, what will happen? All layers will have the space of 1 mm, right? Or apart from each other, 1 mm, they will have the distance of 1 mm from each other. But if we have a feature which is having some, important features like curved surface or some overhang feature, where you want to keep the different value of layer thickness, right? So in that case, adaptive slicing will be required. So it will not only save the feature, or it will improve the quality of that feature, right? Also, it will save our time, because for the planar surfaces or planar sections, we can have the layer thickness of bigger size, or layers with big size. So it will save our time, right? And process aware deposition strategy. For example, you are working on a new process, a novel process, where you are developing a machine which is not compatible with the commercial softwares. In that case, you can write your own tool path. Okay. So here, what I've done, let me show you. Let me show you what I have done basically for one of my project. Okay, let me run this software first, then I will tell you what we have done here. So see what we have done. We have generated a raster toolpath because we have developed our own setup in my lab. Okay, so that particular setup is not compatible with the commercial software, Cura or any other software, right? So what we are doing, we are using MATLAB to generate the toolpath. Okay, so here this code basically which I have run, it is for two layers. So first layer is first toolpath, or first layer toolpath has been generated from stand of distance 0.1 mm, right, from the base. However, the second layer has been generated at 0.6. It means the distance between these two is 0.5 mm. Okay, but base layer will be printed with the standard distance of 0.1 mm. Okay, let me change the number. For example, see, I'm going to change number of layer 5. Okay. Similarly, I am going to change the layer height. Okay, it is okay. And here the layer height 0.1 plus 0.5. So I'm going to reduce it to 0.1. Now you can see what we have done. Okay, so this is my tool path. Okay, so the nozzle will move in this way from 0 0. It will move like this. Then for second layer, it will move from here to here. Then it will start printing second layer. Then so you can see how many layers I have generated so far. 1, 2, 3, 4. Right? 1, 2, 3, 4. So you can generate layers. We can also change the spacing by just changing the code. So this code has been written more especially for our develop setup. Okay. Now, if you compare the code here, I have already pasted my code which I have generated from the MATLAB. So see, this is the comparison. In the standard or the commercial software toolbar, we have some commands also, right? Start heating the bed, start cooling, finish heating the nozzle like this, draw the second line, move the side of the little. But here we have not added commands, but we have added, or we have taken care to keep all the codes, required codes, okay, like M, G,
G1. Okay, so whatever code is required here, E, right? So whatever codes are required to be in the final code, final G code, we have proper, we have taken these things into consideration. Okay. Similarly, here we have G92, G1, G1. So these things we have incorporated, but in different way because we have removed the extra information from the code. So what we do simply we copy this code and we directly load on our machine, and machine starts printing the object. Okay, as per the given code. So we have printed many things using this. Okay. So for example, in this case, we use the okay. This is raster pattern, and where the pattern is same for each layer. If I just try to see the top view, I will see the parallel lines. Why? Because all layers have the similar pattern, right? But in 3D printing, most of the time we use different pattern. One layer is deposited in this way, then second layer is deposited at 90-degree angle. So, so here again, this is the code where we have incorporated this strategy, in which you can see that this is now. If I try to see the view, top view, now you can see the pattern which we are going to have. Okay, now we have the hatching, cross hatching, crisscross pattern. So first layer is having the toolpath at 0-degree orientation. Then second toolpath is at 90-degree orientation. Then third toolpath is at again 0-degree orientation. Then fourth layer is on the 90-degree orientation. Fifth layer is again on the 0-degree orientation. Sixth layer is again on the 90-degree orientation. So in this way, we can use the MATLAB for the toolpath generation purpose. Okay. Now, let me tell you the introduction to creating apps in the MATLAB. Because whatever, so far, whatever I have shown to you, that was in the code form, right? But every time when you are dealing with the codes, it's very difficult because you have seen how I have changed the number of layers, how I have changed the slice thickness, how I have maintained the various vectors by changing the value in the codes. But this is very risky process or very hectic process, because if your code is having, for example, 1000 lines, right, it's very difficult to identify all the parameters because one parameter is defined at various places, multiple places. So every time you have to check your code again and again. Okay. So if you're investing your lot of time in the coding, then when you will do the experimentation, right? So to make I would say the use of these codes easier, MATLAB has a capability to generate an app. So that app can be used directly by the user, where user will only feed the values in the boxes, right? And then user will get the data. Whatever data is there, that will be taken directly from the app. Okay. So need of app design. So let's you create a professional app without having to be a professional software developer. So even though you are not a professional software developer, you can generate your own app. If you have little bit understanding about the coding, okay, you can generate your own app. So today we will learn how to use the MATLAB for app development. Okay, so this is a feature which was introduced in 2016. Okay, and it helps to build your own app with the customized interface. So this is a sample app where you can see the buttons. Push buttons are there, load data, create models, and some edit fields are there where you can feed the values, okay, of different variables, right? And then here you can see the button again, find optimum value, and you can have the slider options by which you can feed the value of the different variables, okay. So earlier, before 2016, MATLAB was providing the guide option. This app designer was not available that time. Guide was available where people were used to make or develop the GUIs, right? GUIs, which was quite similar to app, but app has more, the options or more features because it can be deployed on the web also, right? So I will not waste my time much here. I will directly give you the demo. Okay. So when you click on the the app designer, right? This kind of interface will be appeared in front of you. Sorry, in front of you. So what is it? On the left side, we have component library. Okay, where from you can choose the components as per your requirement. If you want to incorporate the push button in the app, you can take push button. If you want to have a figure, then you can plot the axis, right? You can also take the edit field, numeric edit field text, or you can also take the some other things like image you can show. You can also level the. So this is the component library, and this is the design and layout of the app interface, right? And this is your design canvas, where you will develop your own app by just placing all the components. So all the components will be placed here. Then here we have property panel. So this property panel will give you the value of all the properties or will show you the properties of the selected component. For example, if I have suppose taken this axis here in the design canvas, if I click on the axis, all the properties related to axis will be appeared here. Okay, will be shown. So how can we add component in the design canvas? Just by dragging the components from left to right, right? Left to right. So just drag it. Result, do you have MATLAB there with the participants? Misal, do you have whether the participants has the access of MATLAB there? Which version? So if just ask them to try go in the apps. Okay, go in the apps, right? Okay, and then just click on the first option, design app. Click on this like I am clicking. My computer is taking more time because it is heavily loaded. So have you clicked? Because this is practical session, na? So otherwise it will be very boring for the participant if they are not doing any hands-on now. I want to engage them by just giving the hands-on demonstration. See, if you can do something, then please check. Otherwise, I am also not able to open actually. I don't know why. What is happening? So no one is having the access of MATLAB right now. Hmm? Okay, okay, okay. Hmm. I think if they do not have the setup, then how they will perform? No issue, no issue. Okay. So what I've done, okay, I will do the live demonstration. Okay, I will do in the live mode. Okay. So what I've done under the apps, I have click on the design app, right? Design app. Now I am click on the blank app first, blank app, because I am going to make my own app, right? So upon clicking on the new app, what I'm having on the left side, I'm having the component library, right? And on the right side, I'm having the component browser, and in the middle, I am having the design canvas, right? So so here you can see how I am just placing the components, right? I'm just clicking and dragging the components. I'm just clicking the dragging the components, right? And they are sorry, this I have to be taken. So they are basically is in the design canvas now. Okay. If suppose these are not required. Now what I'm going to do, I'm going to just simply going to make a simple calculator to calculate the force. If the mass and acceleration values are given, okay, F equal to ma, right? I'm going to use here, and I'm simply taking the I'm just going to make a simple calculator to calculate the force. Okay. So what I've done, I have taken two edit field numeric. Okay. And here I'm changing the value, sorry, name, that is mass, right? And here I am taking the acceleration, for example. Okay. So if I click on mass on the right side, I am able to see it, the properties. Font, suppose you want to change the font, you can click on the bold. So now it is bold, it is not bold, right? Font color, black to, for example, red, yellow. Okay, so whatever font color you want to keep, you can, right? Background color is also there. So currently we have taken white. You want to keep it yellow, you can take. So from the property side, you can change the variables, right? Change things according to your use, right? So again, here also I am going to take the same thing, the same color, not same color exactly, the this color, right? So what I've taken here, I have just wait. Okay, so I have taken these two things here. Now I will take a push button. Push button means once when I will feed the value in the mass edit field and acceleration edit field, I will press the push button to get the value of force. So here I'm just writing calculate, 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 right? And again, I will take another edit field box where I will show the value of force, right? So for this, I am going to change the color also, right? And for calculate, I am going to take red color. Okay. Then font color in the red, we will keep the No, not this one. This one is, I think, this seems good. Similarly, I can also change the font size, right? Font name also. So calculate. For example, this is my calculate button. Okay. Now, in order to make it executable working condition, I will simply go in the because I have to make it functional, calculate. Because currently, if I suppose run this program, what will happen? Let's suppose F1 MNIT, for example, MNIT, and here I am writing force, for example, right? If I simply write it, right, or simply run it, what will happen? This is my app. So now if I'm calculate, if I write something here, for example, 10, I'm giving the value of 10 here, nothing is happening. When I'm clicking on this, nothing is coming in the force because we have not connected these boxes together. We have not defined anything yet. Okay. So here what we will do, we will connect the, we will establish the connection by clicking the, by just writing few lines. So lines are because I have written mass, not mass kg, ACC. Yes. So what I have done, I have defined mass equal to app dot mass edit field, because what we have taken here, we have taken the mass edit field with the name of mass, right? But in my PPT, I took mass bracket kg. See the difference. Mass kg, mass ms2 meter per second square acceleration, right? But here I'm not defining any unit or anything else. Just I'm simply connecting the callbacks. Okay. So under calculate, just click on calculate and click on right click on the calculate, and it will go to you here, right, where you can write your own code. So what I've done here, I have written mass equal to app dot mass field. So this function or this edit field, I have already defined my edit field by using the name mass. So I am writing mass here. So whatever value I will feed in this edit field, it will be taken as a mass value, right? Similarly, for acceleration, I have taken the name ACC in my case. So app.acc edit field value. So whatever value I will feed here, it will be taken as the taken as acceleration value, right? And here, what I have done, force equal to mass into acceleration, F equal to ma. So this force value will be stored after the multiplying these two things, whatever value we will feed. So right. So this force value will be displayed where? Here. Here. So this is the force added field. What is this? Force added field, right? So we are going to show this value in this edit field only. So that's why we have written that force app dot force edit field dot value equal to force. So it will display, all the values, right? All the value means the value of force after calculation or after multiplying the mass and acceleration. So let me run this. Let me check it whether it is working or not. So 10, for example, 10. So see what I'm getting. I am getting 100, and simply now I do not need to go for the change in the code. I will simply change here only. Now I'm changing mass to 100. So value is 1000 now. Now I'm changing mass to 85. Now value will be 850. Now I am changing acceleration also from 10 to 12. 85 into 12. Right? Is that clear? Now, good. Another app which I have created today. Let me show you this app. So this is another app which I have created today for you. Here, suppose I want to calculate the compounded interest and simple interest. Okay, and principal amount is for, let's say, 10,000 rupees at 5% interest rate. Time is around 12 months. Calculate. So what it is giving me? It is giving the simple interest and the compounded interest, right? So all the formulas I have I have incorporated, I have added on the back side or under the callbacks of the calculate. So to show the formula, let me open this interest app. Yeah, so okay. So this is my again the depth designer where I have dragged these things here. Okay, principal, rate, time, calculate. So under the calculate, I have written call. See, so amount means what is the principal amount, right? So principal amount is the app dot, because I have defined my edit field with principal name. Principal. If you look at here, what is the name of principal edit field? What is the first edit field? Principal. Principal. And so this is the principal app dot principal, and this is the edit field which we have taken. Okay. So edit field which is having the principal name. So whatever value we will add in this edit field, this will be treated as an amount, right? Now, the second thing, rate, interest rate. So in my design view, if I go back, I have defined this edit field with rate, RATE, where R is capital. So what I have defined, rate is the value which will be fed into the second edit field with the name of rat. So app, this is very simple. You have to write only app dot rate edit field dot value, right? Divide by 100. So this is in the actually percentage we are feeding, and it will be converted into the number. Then third is the time. So again, what time we have taken app dot time edit field dot value, right? So for simple interest, we have used this formula, and output we have shown or we have displayed in this edit field value. So whatever compounded interest we have calculated based on the formula, this will be displayed here. So what is this? App dot compound interest, and we have defined our own edit field with this name only, compound interest. So here I want to display the output, right? I want to display the output of compound interest. So that's why I have written app dot compound interest edit field dot value equal to compounded interest which we have calculated from the previous line, right? Similarly, simple interest, it will be displayed here. it will be displayed here. F dot simple interest added field dot value equal to simple interest. So that is why it is showing the simple interest value in the added field box, right? So now if I just run it 10, so not 10 actually, as I run earlier, now I'm taking 5,000 and 20% rate and for 6 months. Okay. So now it is giving me the value. Okay. 6,000 simple interest, compound interest is 9,930 after 6 months. Okay. Now, very important. Okay, one more thing that I want to discuss with you, that is the yes, this is slider. It is not mandatory to give the value always input value using the edit field. You can also define or you can also feed the value input values to the app using some other options. Like here in this case, I have developed this slider. Okay. So here I have, let me check whether which option is working right now. So I'm writing this simply 10 and 10. And let me check whether it is giving me the value of force. No, it is not giving, right? So whatever I'm writing here, it is not taking because I have given the value of mass from this slider. So from this slider, the value is 20 right now. So this is the mass value. Now let me check. This is not exactly 20. This may be 20.8 something, right? Now again, if I calculate, it is taking because exactly the slider is at the 76. So 76 into 10, it is giving me 760. So how can we put slider in the app, right? So that is the part of discussion. Okay, so again, I have taken this slider here. Okay, so currently this slider is laying in the horizontal or the in this orientation only. I want to suppose keep it like this, then it is also possible. Okay, slider. This is slider, right? So what I have done here, let me show you. Instead of taking the mass value from the edit field box, here I have commented this line. This line say that mass equal to app dot mass edit field dot value. So I have commented this line deliberately because I want to use this slider, okay, to give the mass value. So that's why what I have written, mass equal to app dot slider dot value, right? App dot slider dot value. So whatever value, whatever the position of slider will be there, it will be treated as mass, right? And suppose the same thing I want to do for this acceleration, then what I will do? I will add another slider. Okay, let me check. Okay, let me add another slider here. So with this slider, this is slider. This is the slider, right? So this is slider 2, right? Now, what I'm going to do, I'm going to check the name of this slider. This is app.slider2. App.slider2. So what I will do, I will also comment this. Okay. And I will add one more line, that is the ACC equal to app. Oh, sorry. App dot slider. This slider 1 or 2? 2 dot value. So similar to this, I have assigned the slider acceleration value to the slider. Earlier, the acceleration value was taken from the edit field. Now, the same value will be taken from the slider. Rest things are same. I'm not going to change. Right? Now, let me check my app whether it is working or not. So here I'm writing 10. Okay. Here 10. Let me press calculate. No, nothing is happening. Okay. Okay. Let us do another change. I'm just using this slider. Now calculating, nothing is happening. Why? Because it is not interacting with this. It is taking the mass value only from here, from slider 1. Because slider 2 at 0. So that's why multiplier of these two is 0, right? 40 into 2, 0, 0. So now if I slide this to 40, now what is happening? See, 40 and 40, 600. 60 and 14 exactly, if I keep it at 60, not 60 exactly, it is not at 60 because the scale is not clear. See, okay. So now it is interacting. Now I can delete these two. Right? Okay. Now let me do one thing. Let me deploy this app or the apps which we have developed as a application file. As a application file. Okay. So application file means in the designer, I will go in the share, right? And currently I have selected this file. So no, I am not going to save this. I am going to take this interest file. Okay. So I'm just going in this share where I am having three options to share my app as a MATLAB app. Okay. So if simply the other user will have the MATLAB, they can use this app easily after installation. Second is the web app. Web app means the data on the files will be created that can be deployed on the web, or that can be uploaded on the web page. Okay. And third is the standalone desktop app. So it can be installed at any desktop. So third one is very important. Okay, if you have created an app in laptop and you want to transfer it in the computer or is on or any other system, okay, for the use for the application purpose, then you can directly transfer the exe file. So what I'm going to do, I'm going to create the standalone file for the interest_1. Okay. So see here the name is interest_1. So I'm just changing its name to interest calculator, right? And here the version name 1.0, 2.0, 3.0, 5.0. Author name, suppose I am writing my name Narendra Kumar, right? Kumar and @nitj.ac.in. Company, for example, I am writing NIT Jalandhar. Okay. Summary. Developed
during FDP at MNIT Jaipur. For example, this is my description and all. So if I want to add these things, I can. I can also select uh, the picture, right? The picture. So for example, I want to keep this one. For example, this one. Okay. So instead of by default picture, now it is taking this image, right? Mountains and river. Okay. I'm skipping other things now because it is sufficient. So it will, see here the information is files installed for your end user. So interest calculator will be there as a exe file, readme file will be there, and the image which we have already used. So this will be there. Now, uh, now let me package it. Okay, no, it is just downloaded. Okay. So now it is packaging my app, right? So after the means packaging, it has opened a folder where I am having these files. So for C, this is the application type. You can see the type. You can see the type here, application. So I am just opening it. I am going to install it in my PC. So you can see the image which we imported earlier in the MATLAB. It is shown here. Okay. So preparing for installation. So it is taking a few minutes. I hope it should be installed quickly. See, after pressing the installation button, it is showing some information. Interest calculator 1.0 developed during FDP at MNIT Jaipur, and here the author name, right? I'm just clicking on next, and where I want to install it, I want to install in the C programming, C drive, program files, and Additive interest calculator. Okay, or I can also add shortcut on my desktop. It is very similar to the applications which we generally install in the computers. Okay, MATLAB runtime, next, right? So after confirmation, we will be able to use it. So did you accept the license agreement? Yes. MATLAB runtime, no technical, some the user license rated, the conditions are given here, right? Next, do you accept? Yes, I accept it. Begin install. So it is saying the time how much time will be required. Okay, so it will take, I think, 2 GB file has been created. So in this way, you can easily make your own file. You can execute. You can also generate the application file, right? If it is installed quickly, then I will show you. Otherwise, I can terminate this also if you have understood, because I want to show you mesh mixture, right? So I'm quitting it. I hope you have understood the process, right? So that you can install, you can make any app. No need to open MATLAB again and again. Simply deal with the labs apps and use it for your own purpose. Okay, but you should have the idea how to generate the app, because in the app you can also write programs for 3D printing, because all the softwares, right, which we usually use for 3D printing, those softwares can also be developed easily with this. So MATLAB has also various ready-made commands for STL writing, reading, and all. Okay, for slicing also very small codes are there. So you can search, you can develop your own app. Okay, so this is this was discussion on MATLAB. Now let me show you quickly the use of mesh mixture as I promised you earlier. So this is the mesh mixture, right? Which I am going to show you. I think I have not. Yes. So this is mesh mixture, right? Can you see my screen? Okay. So this is mesh mixture, right? And here I will show you the application of the software in 3D printing, right? So here what I'm going to do, I'm going to give you quick overview of the STL file. So as I told you, for the small product, right, like cube, you can count the number of STL triangles. But if the file size is too high and it is having some curved surfaces like this, in this case, you will face some of the issues. What are those issues? Because STL file quality may be deteriorated due to the less number of triangles, right? Sometimes your STL file may have the errors, right? So here I have taken 3 cases. First, so before giving you the demonstration on the software, here I am discussing thing very important related to discussion. So here you can see we have 3 cases. 3 models are same, but we have exported them in by using different parameters. So due to this, here in the first case, the number of triangles are 668. In the second case, number of triangles are 1086. In the third case, number of triangles are 1380. Right. So all the files are having the differences in terms of number of triangles and in terms of quality, which we cannot see from the naked eye. But from the naked eye, we can observe the differences in these 3 STL files. So first one is the coarse STL file, right? If you look at the size, right, file size, the first one is only 705 KB. Second one is 2760 KB, and third is 17350. It means 17,350 KB. And with this size, you can see the improvement in the quality, isn't it? So you can see the quality. In the first one, the surface is very coarse, rough surface, right? Like this. This is the rough surface, right? And again, further, when I increase the number of triangles, the surface has been refined, right? Or little bit
it improve if I compare it with this first one? This is second case. This is third case. But further I increase the number of triangles. Quality is too good. Now I cannot find the difference between the actual CAD model and the STL file. But still difference is there, but we cannot see it from the naked eye. Okay. But if we compare these three cases, obviously last one is the good. If suppose your objective is to print the parts with high quality, with high surface finish, in that case, obviously third option will be selected without any doubt, right? And as a 3D printing user, right? Sometimes we do not know the quality of STL file. We do not know about the quality, because what we do, we directly download the STL file from the internet, right? And without checking the STL file, we go for printing. So what happens after printing? Obviously, when you get the very wet surface finish, right? Then you try to optimize the process parameter. But question is, if your STL file is not optimized properly, then what is the purpose to optimize the process parameter? You will never get the good surface finish in the printed parts if your STL file is having the error, or not error exactly, not having the good quality, or it is the coarse STL file, right? So it's very important, before going for the printing or before processing STL file for further slicing and all and paper generation, you have to check your STL file, right? So now with this, let me start my discussion with the mass mixture. Quickly I will finish because I have to attend another meeting at 4 o'clock. Okay. So in 10 minutes, I will give you the idea how can you use mass mixture. Okay. Or in some other day, I will cover this particular uh, software in detail. Okay. So see, this is the uh, software screen, right, for the interface of the software. Although the software has been, developed by the Autodesk, but nowadays they are not, upgrading this, because this is free software, right? And they have already, I think, merged the software with their I don't know the name of the software exactly right now, but they have merged these features with some other software. That's why they're not upgrading the software right now. But still, this is very good software. This is sufficient for the meshing and remeshing. A lot of things can be done here easily. So here, what I've done, I have imported this particular model here, right? Bunny model, and from the this panel, I can select my printer. So for example, I am having a Ultimaker printer with me. Okay. So if I select the Ultimaker printer, obviously the print bed will be automatically resized. Okay. And here I am getting this Ultimaker to go. Okay. Now, what I'm going to do, I'm going to change the wireframe view in the wireframe. Why? Because I will inspect my STL file first. So upon inspection, I found that, okay, let me change the, okay. So upon inspection, I found a gap at bottom of the bunny model. So this gap should be fixed. Okay. If STL file is having the error, okay, error, then it cannot be processed. So here I have few options like flat fill, minimal fill, and a smooth fill. If I go for a smooth fill, what will happen? It will change my geometry because smoothly it has filled in the continuity with the upper surface. It has added a new surface at the bottom, but this is not required. So what I will do, I will prepare it with the flat fill, right? So now the hole has been prepared, right? Uh, right. So this is done. Now, now can you tell me the number of triangles? No, because it is not visible here. Otherwise, you can read easily. Sometimes it is the number actually comes at the bottom, but now I'm not able to see it here. Okay, but you can count because here number is given. Okay. Now what I will do, I will select the, suppose I want to remesh it, this area. This area I want to remesh. So I can go in the after this, I can go in the edit. I can also remesh it, right? Remesh means I can change density. I can change, see the size of the triangles, right? So when I increase the decrease the number of triangles, or increase the size of the triangle, the geometry has been removed, right? Or geometry is affected. So if I change it like this, okay, again I reduce the length. No, it will not work because due to the capacity of PC, right? So you can see the difference. Earlier we were having this mesh size, okay? Or the you can compare the triangle size. Here the triangles are very tiny, but here the triangle size is greater than this. So obviously, when you want to capture the curved surfaces, we have to go for the small triangles. So now you can see the difference, right? And suppose one more thing that I want to show you. Suppose I have deleted deliberately these triangles. Now the STL has error. It has been punctured deliberately. Okay. If you find any hole, for hole checking, you can analyze your STL file, inspector command, and it will give you the reason immediately. Okay, this is the reason where we have a hole. If hole is there, hole persists, we can fill it. But here again, we have three options: flat fill, minimal fill, smooth fill. So here, if I go for flat fill, it will not work for me because although I'm not able to see it from the naked eye, but it will not work for me because this is not the flat surface. So instead of this, what I will do, I will go for smooth fill. Okay, now I'm not able to see it. Where was my exactly hole in the STL? And the other feature which is available, that is the uh, see brushes. So under brushes we have a I think zipper. Yes. I'm not able to select actually exact brush because of the screen size limitation. Refine, reduce, cheaper edges. See, it is chipping the edges. See, right? So this is my another option which can be used to just zip the hole. So it means manual stitching is possible and also the automatic stitching is possible, right? If I want to flatten the surface, for example, so let me change the size of the brush. For example, I want to flat the surface. Here I was having the curvature. Now I want to make it flat. So you can see surface has been flattened now. So here we have the inflate. I can also inflate. See. So any other software which is having the features for CAD modeling, these features are not there, right? So because 3D printing basically known for the complexity, so we can put more complexity in the models by just playing with these features. For example, I want to change it. For example, I want to do this. Okay, I want to do this. I want to make a artifact that is not available in the market. Okay, so this kind of things I can do. I can do lot of things. Okay, bubble smooth is there, which can smoothen the surface again. So with this, I conclude my lecture. Okay, because lot of things are there for discussion, but due to the time limitations, I cannot cover all the features. Okay, but if you are interested, please be connected with me. I will be happy to share my thoughts. Okay, share my opinions and share my knowledge with you. So now I will take few queries from you, right? Because I have to go for some other meeting. Bizal, this is from my side.
Anybody having any query may write their query in the chat box.
So I think I have given, I think, idea how to use MATLAB and Mass Picture for 3D printing.
So there does not seem to be any query.
Okay.
So thank you so much, Dr. Narendra Kumar, for sir, for that deeply insightful and engaging session. We truly appreciate you taking the time to share your expertise with us. On behalf of the organizing team and all the participants, thank you once again for joining us and making this session such a meaningful part of the program. Let us give Dr. Narendra Kumar sir a big virtual round of applause.
Okay, thank you. Thank you. I don't know your name, and thank you so much for all of you for your time. Right. Again, we will meet on day after tomorrow. Thank you.
Thank you so much.
Okay.
Now all the participants, we'll have a 20 minutes break and we'll rejoin at 4:20 for the next session. Thank you so much.